Urban landscaping can increase stormwater nutrient loads. Urban vegetation is typically treated as part of the solution to stormwater pollution, intercepting rainfall and slowing runoff before it reaches drainage systems. A new study out of Hefei, China, finds that benefit comes with a less visible trade-off. Rainfall passing through a plant canopy can pick up more nitrogen, phosphorus, and dissolved organic carbon than it contained when it fell. Researchers from the Hefei Institutes of Physical Science, Chinese Academy of Sciences, and collaborating universities monitored 8 urban landscape species, 5 shrubs, and 3 arbors on a campus near the Dongpu Reservoir within the Chaohu Lake Basin. Across 17 storm events from April to July, they collected paired samples of incident rainfall and throughfall, the water that drips through leaves and branches, to see whether vegetation simply filtered precipitation or changed its chemistry. Arbor throughfall adds 434 kilograms per square foot of nitrogen. Shrub throughfall adds 3.5x more phosphorus. The two vegetation types produce different pollution profiles. Arbor throughfall drove the larger nitrogen increase, with total nitrogen flux rising by about 434 kilograms per square kilometer relative to incident rainfall. Shrub throughfall, meanwhile, produced a net phosphorus increase roughly 3.5x greater than under arbors, along with the highest dissolved organic carbon export of the 3 sample types. That split matters because nitrogen, phosphorus, and organic carbon create different downstream problems. Nitrogen contributes to nutrient loading and nitrate accumulation. Phosphorus is a central driver of algal blooms in freshwater systems, which made the Chaohu Lake Basin, a lake already prone to eutrophication, a relevant test site. High organic carbon concentrations can affect dissolved oxygen, microbial activity, and the formation of disinfection byproducts at drinking water treatment plants. The researchers note the findings do not mean landscaping itself is harmful or that green infrastructure should be reduced. Shrubs in the study retained more rainwater than arbors did, reinforcing their runoff volume value. The gap is that stormwater systems are typically sized around how much water vegetation captures, without accounting for what the canopy adds to that water before it reaches the ground. Shrub throughfall also carried more high molecular weight organic compounds than arbor throughfall, which the researchers say could pose added treatment challenges, including membrane fouling risk and reduced infiltration if that material accumulates in permeable pavement. The study found statistical associations between dissolved organic matter and metallic elements in the samples, suggesting canopy-derived carbon may help transport some pollutants, though the researchers did not directly measure metal binding, so that mechanism remains a proposed explanation rather than a confirmed one. Plant selection is becoming a factor in stormwater system design. For facilities, campuses, and municipalities managing stormwater through green infrastructure, the practical takeaway is that plant selection functions as part of the engineering, not just the landscaping. Shrub-heavy plantings near outfalls or sensitive freshwater bodies may warrant phosphorus-retaining media or added bioretention capacity, while nitrogen-leaching arbor stands may call for different treatment pairing. That documentation matters for more than water quality outcomes. Stormwater plans are already one of the compliance categories regulators flag most often when a facility's paperwork hasn't kept pace with how a site actually functions. And the same organic carbon dynamics identified here are relevant to the treatment side cost and liability questions utilities are already weighing for other persistent contaminants. The study was conducted at a single site over one spring to summer period and did not measure stem flow, the water that runs down trunks and stems rather than dripping from the canopy. So the specific figures should not be read as universal values for every species, climate, or season. The researchers frame the results as a starting point. Green infrastructure should be evaluated not only by how much rainfall it holds, but by the chemistry of what it releases. You've been listening to Sustainability Soundbites by Environment and Energy Leader. For partnership opportunities, please reach out to our team.